folks who can't make it at times. I'm going to start texting people. So look at it for a second. Hopefully the setup does look familiar. And once you have checked through your mind and checked through, hopefully, notebooks, should be something in there to assist you. And if still I'm seeing nothing's clicking, then I'll point out what are we supposed to do with this.
You want us to solve it, right?
Yeah, solve it. Solve it. Get all the way down to the remainder. And then if it fits below on your screen, you can translate it back. Then we're going to talk about what was the actual problem? What would it look like? Because usually when you have these types of problems, they don't give it to you set up with the synthetic division, big L, little thing, or however they're writing it. Most people do use this format. Admentum doesn't. It uses something that looks slightly different. Some people use that. This is the more traditional way. This is the way I remember seeing it 20 plus years ago in high school. And evidently some websites agree with me that it looks like this.
And then, like, this week's going to be because my little brother's in a competitive basketball team.
Very active. Is that the one I hear in the background? Or is that the only one?
That's the one you hear in the background.
Mm-hmm.
He made it to the comp team. So I was like, oh, that's actually pretty cool.
Good. All of you drop the one at the beginning. And then what did you do? Inform whoever just arrived where we're at. Hello, Sky. So we're on the whiteboard site, Sky, with some problems that you've seen before, hopefully, to see if you remember how to do it, if not for me to fill in and to see your steps. Because I think about 40% of lesson 2 is you being able to do this thing. This is what we do when we don't know. The problem looks like we can factor it, but then we try to factor it, and then we end up like, wait, did I factor it wrong? How come it's not working? It has a pattern that is not one of our basic nor advanced factoring styles. I'm going to double check when we answer. Let me see. 1 goes down. 2 times 1 is 2. Let me see. Notebook. Angelina calculate. So you should have 1 on the first column at the bottom. You did 2 times 1 is 2. -3 and 2 is -1. That's correct. 3. All 3 of you have that part. And then -1 times 2 is -2, which Jasmine wrote down the wrong number.
Wait, wrong number?
So you below the -11, there should be a -2, Jasmine. That's why your stuff started getting like really, really big.
Oh.
Okay, the -13s for Gemma and Angelina look fine. Then we do -13 times 2 is -26, which that should be below the 5. Should be a -26 below the 5. -21. Wait, how did they get that answer? Did I write it down? Let me see. -3, 517. Okay. Just for my curiosity, we'll be checking the website I was looking at for these problems. according to what I saw earlier. Wait, did we mess up from the second step? Let me look at your guys' stuff again. Check one more time. Let's see. -3. Morning, Julian. Go to the whiteboard side. That way you can see what problem I've written down. Some of them are on there.
So since we're transferring all the numbers to the log,
Oh, I see what I did. That's why. Because I kept on erasing. So let me say it, Jasmine, since you're
so
transferring.
would it be like x3 when it comes to translating, since there's an x4 and a big L? Would it be like x3, x2, x number, and then the remainder?
Yes. And I'm going to write down the stuff just to remind you what we're looking at. So let's see, this is less than 2. You're in unit 4. What are we doing? We're doing synthetic division. Let me aim the camera. It should be. We're doing synthetic division. What does that look like? It looks like you're doing a big L. Okay, so what we just did was this. The reason why we didn't get the answer that I thought we were supposed to get, I put a positive 2 out here. We'll work with it. The numbers would have been slightly smaller if I would have put the negative. But the 3 of you got the right thing, which was the 3 of you on the whiteboard side, which was negative 25, I think.
Yeah.
So we put a positive 12 here. Again, me putting the categories up here is more of a thing I've been doing since at OFY, and I've noticed the Math 3 people seem to like it, and it's helpful for them to be accurate. They make less mistakes. Usually, if you were to look up, like on the websites where I got these problems, nobody does that, basically. Maybe just when they're introducing what the categories are, but I think it's easier for us to retranslate them and all that. And it doesn't take you too much time. And you're going to see after we do the 3 review problems, because we're retrieving stuff, because this is stuff you've seen before. And I probably should have spaced these out a little bit more, but we'll work with this. So we had a 1, -3, -11, 5, and 17. Now straight looking at, okay, just for the video's sake, because if not, they're just going to see what you guys wrote on the whiteboards, which was correct. We dropped that one down. 2 times 1 is 2. -3 plus 2 is -1. -1 times 2, so 2 times -1, it bounces up. -2. Here's -13. 2 times -13 is -26. Here's where my spacing, better spacing would help you out. You have to pause for a second, think to yourself, okay, are you seeing this? Like I was telling Jasmine before, were any of you out and about on Friday when it was like really foggy or anywhere foggy? Jasmine was out in the weekend in Davis. Any of you out in the fog at any point? Because if you were like me, driving from Elk Grove back to over here, East Sac, okay, I was going down Stockton Boulevard most of a little chunk of the freeway, which at first, the good thing on the chunk of the freeway from Elk Grove to like where the Costco's out over there in South Sac, good thing people were being more normal right there and being like cautious, because like I'm assuming most of us haven't been in places where it's been foggy since the pandemic. So like people were driving like all cautious and slow and stuff. I'm like, okay. But then I got off and it was like really, really foggy on Stockton Boulevard. Couldn't even see the lines. I know that street fairly well, going all my life to different businesses there. Kind of thing, but sort of like this. You have to make sure that your eyes, even though they're tired or whatever, after acupuncture and stuff like that and a week of work, you have to make sure that you're lining it up. Now you're going to hit somebody. Okay. And there was somebody out there, if you know where the Popeyes and the Lunch on Silver is at, jaywalking in the middle of the street in the dark in the fog with heck of cars. I'm like, why are you doing that? You don't appreciate your life or something? So these line up. Okay, there's more negatives. I know it's negative. negative 21, because 26 minus 5 is negative 21. And then that one's negative 42. And I remember that the three ladies on the whiteboard site got negative 25. Then we have to translate it back. Whatever's on the right side, remember when you finish the thing, who's grading your stuff? That's me. That's my first initial. R for Rodrigo. This is the remainder. Then you're going to have these categories from the top, but backwards. You start on the right. This one becomes the number. This one's whatever letter you're using, x in this case. X squared, x to the third power. So what this translates to is 1x cubed. That is not going to fit right there. I'll put it below. X cubed minus 1x squared minus 13x minus 21 with a remainder of negative 25. The remainder is a fraction. Negative 25 over what? Over things related to what's on the outside. This outside number is like x equals 2. Where did it come from? It came from the fact that there was a small equation that equals 0. If I make this equal to 0, without even knowing it, I know that my second part to my problem, whether they told me some long thing divided by this, check that out, find me the remainder, or they wrote it in as a fraction, this would be on the bottom. Okay. So this would end up being your answer. You're able to chop it up into a bunch of different pieces. You got a little fraction going on. You got some change over here. Okay. We're going to be doing 2 more like this. What I'm also going to do on the sideboard now in a second. This guys started popping in. Thank you for arriving. One thing I'm going to try with the technology is for those of you who haven't been in class for a while and I said I was going to record some videos. It's not that I didn't try. Those who have been in class, especially the one in the room, know that I have been trying, but the Chromebook keeps on erasing it or freezing and then erasing it or not freezing at all and then the video goes away. So keep on trying. I'm going to, starting tomorrow when I have more energy, bring mine in. I'm going to try to pause the recording for class today in the middle to see if that helps out, making 2 half-an-hour videos maybe. So now let's translate the problem so you can see originally what was this. What I'm going to be doing, I'm going to look up here at the categories. So notice 1, x to the 4th. Over here on the sideboard, I'm writing that, x to the 4th. It says negative 3x to the 3rd. Negative 3x to the 3rd. Hopefully it doesn't make you dizzy, but I'm going to be going side to side for those at home. So notice. So for I have x to the 4th, negative x to the 3rd. The next 2, negative 11 and 5. So negative 11 x squared. Notice that this problem has like all the different categories from x to the 4th all the way down. That doesn't have to be true. Edmonton, for some reason, at least through the practice on the ones I've seen, is doing that. I don't know if it's going to throw it out just on your mastery test. Ones that don't have all the categories. If it does, want you to be ready. That's why you're going to see the next problem. Okay, so translating this inside part to a polynomial. It's a combination, a bunch of letters and numbers, just addition and subtraction. That's this. You just did this divided by, which can have the little division symbol or be written in fraction form. This was problem number 1. This is what it looks like. Problem number 2 is going to be.
Wait, this is the same problem, right?
This is the same problem. This is what I put on the whiteboard for you originally.
Oh.
The 3 of you did it originally with just the numbers, ignoring the variables. Well, we sort of had them in the category, in the little heading part. Okay. And let me grab the next one. Problem number 2 is going to be the following. I'm going to write it in the different format. Because just like you're in class with Vanessa, or doing English in a packet, or on Edmentum, the whole point of that is for you who are already either bilingual or a native monolingual English speaker to be able to speak to people, I don't know, in a professional setting, be able to read traditional books, and expand your knowledge of English because we all speak it. Some of us can code switch depending on our communities and other things we know about. So these two problems are the same type of problem, but notice they look different. This one has that symbol for division. The other one has it in fraction form. This, I've already translated for you on the whiteboard site, which if you haven't gotten yourself over there, you need to get yourself over there. That's how I can evaluate, do you know how to do this? Again, for those who were here from the beginning, I'd mentioned this skill is 40% of less than 2. Okay? It's just you messing with the numbers, and if you're the thing throwing you off is I see negative numbers there and I'm combining them, do I subtract, add, or whatever, you have a calculator to use the calculator. As long as you can line things up. So get on the whiteboard site because I'm going to send over number 2 to people.
Rodrigo, I can't use the whiteboard site because I'm using my phone. I don't have internet here. I'm in Mexico.
¿Qué andas haciendo allá? You're
visiting.
Why? Just like Mexicans be randomly leaving at times when they're not supposed to. Be sounding like when my mom was alive, she was talking about my dad's family that my grandma on that side would do that to my cousins in the middle. Let's just go on the middle and just say like your grandma died or something kind of thing. So like supposedly my
as long as I'm showing up to class, it's all good.
Well, now you have technology, so you don't have excuse because my tias would just disappear from high school all of a sudden. Like, oh, now they're back and they graduated somehow back in the day. So what we're going to be doing. Oh, también that whiteboard site does work on your phone, by the way. And plus your phone's touchscreen, so technically, si se podría. Well, do it on paper, send me pictures. That goes for the rest of you, kind of thing. So you're responsible for somehow letting me see. Well, obviously, if it's on paper and with pictures, it can't be in real time, but let me see, what is it that you're writing? Are you on the right track? Or I can see, are you lining it up wrong? I was able to spot some mistakes and say, no, this number under this one, change it to something else. So again, that's the original problem. Let me erase the other board so that those with the technological difficulties. Just like one of my IS students who their other teacher informed me that gentleman's going to be in Hawaii. I'm like, another one? I had another one a couple weeks ago who was over there. So again, when we're translating things, so some of you get on, because you already have it set up, big L. What's my first category? It says x to the 5th. So that means that I need to go from x to the 5th all the way down to numbers. Even though I don't have some of these categories, I still have to write them down. If I were to do this, by the way, this is not the long way. Okay. You will see that after the third problem. We'll do one like that, and you'll see that I don't like that way. We only use that other method if we have to. There is an advanced version of this also. I need to rewatch the video. I didn't have time last night to do that. Seen it once or twice, and okay, sort of makes sense, but I need a refresher kind of thing. So we have this thing. It says x minus 1 on the second little chunk, which is over here. This is why we need to put x positive 1. We do the opposite of that number, or we solve that, equaling it to 0. We have one of these. We have negative 3 of those. We have 4 of these. And we don't have any of these, so we need to put a 0. Bring it down and see what you can do. Okay. So those with not able to get to the whiteboard site, you're responsible for sending me some pictures, so I should be getting notifications and stuff like that. We're supposed to have one of my new students connect herself today, convince new independent study student to join you guys. She's actually in Math 3. We'll see what happened because she evidently didn't connect. Let me send it to Tino. Oops. I think I clicked the wrong thing. There we go. Let me check my notes to see. Let me see if I wrote it down this right exactly. As it should be. Oh, this time I did write it. And I got two of you who agree on the answer. I'm just curious to see if I wrote down the problem accurately because it was going very, very quickly. Wait, this one's not this one. Where did I get this problem from? Check the answer. Okay, so I'm going to check the workout on a couple on the whiteboard. So I have two who have the same answer of remainder 3. One has an answer remainder 1. Let's see. I know, I can see that. Let's see what happens. So we drop the 1, and make sure the camera's still in the right spot. We drop the 1, and then you check your work because for the recording's sake, you need to have it aimed at this thing. Then we're going to go 1 times 1 is 1. 0 plus 1 is 1. If I say something or I write down something, more importantly, if I write down the thing that doesn't match up to what it should be, let me know. Did I mess up already?
Is it like supposed to be a negative one though?
No. The reason why, so to point that thing out, after the division sign, we have x minus 1. Because we're trying to check if this is a factor of the big long thing, meaning can it divide it out evenly? If that is true, that means that this is a 0, meaning make an equation equal to 0. Meaning the number we have to check is this number. That guy, 1.
Wait, also, isn't the negative 3 on the x to the or third power should be negative 1 though?
Let me see.
Because on the whiteboard it says
it says negative 1 here?
Yeah.
Okay, thank you. So that's going to throw off people if they were doing it not on the whiteboard. And this one's a negative, right? I think.
Negative 4 and then negative 1.
Okay. So now I've made the edit, so it should be a negative 1 here, negative 4, negative 1. I don't think that's the issue because the 3 that I sent it over to do have it like that. Okay.
Mr. Rodrigo?
Yeah.
The one on the outside and the wiper side, it's negative. But on the physical board, it's positive.
It shouldn't be negative. Let's change it up.
Yeah, that's why.
Let's reset the thing.
It's okay.
It's a Monday morning.
Yeah.
That's why we make mistakes. It might have been that you and Jasmine did do the problem right according to the negative 1 thing right there.
Oh, no,
Let me resend it out to the 4 of you who are on the whiteboard site. This is how learning looks. You're not going to do it at the first try. For example, one time I was watching a documentary about Picasso, who I'm assuming that name sounds familiar, about his process for making one of his famous paintings. He's painting something about the beach, and it's like time-lapsed. The thing takes like half an hour to watch, but evidently it's like, I don't know, like 20 hours or something kind of thing. And he's like moving the people around, changing the colors that he's painting over and over and over again until he finally likes it the way it should be. Because you're not going to do it in one shot unless you have the type of painting like Jasmine, sit there, I'm going to draw you kind of thing. I have the thing, and if it's a quick, that kind of thing. Okay, so those on the whiteboard, retry with the correct numbers. And then we'll see if we get the same thing up here. I'll try not talking. Those who are just looking here at the camera, you'll be able to do it. So this goes down. You're always bouncing the outside times the bottom. 1, 2, 3. This. This gets to that. That is this. Okay. Let me double check stuff.
Okay, my answer's different now.
Mine sounds like what I heard you saying, but for some reason it's not the thing that's on the website. Don't know why.
No, maybe because I'm wrong. I don't know. 0 minus 1, 1.
This is this. Let me see. This is what I got.
That's what I got too.
Let me see what Angelina and Giselle got. See, we're all getting the same thing. Are we doing it all wrong? Or we're leaving it that way? Let's see. 1, 0. Oh, this is correct. I wrote down. Oh, we're gonna do some edits in a second. Of that side, we're not doing this one again. Evidently, see, this is modeling why, because I was writing this on the whiteboard as I was talking to Jasmine about her brother's soccer tournaments and the fog and stuff. That's why you don't do that 5 minutes before class. Okay, these numbers, we're sticking with them. But notice 1, -1, 4, -4, -1. There was a 3 there that Jasmine pointed out. The whiteboard doesn't say that, but it should have. So we're going to change this right here. Easier edit. 1, -1, -4, -1. Our answer matches up to this problem, not with a -3 there. That's why it was looking different. Our -5 is correct. Okay. Next time I'll go back to writing my whiteboard problems in order of chronological for the classes. I wrote down the math 2 people's stuff first instead of your guys'. Usually I do the math 3 people first. And I'm doing theirs at the last moment. Okay, now let's translate this back. What category is this -5? What category is this -5? I want to write something below it.
A remainder?
It's a remainder. So that means this is the last original category. What's that? That's why I find this helpful. That's this, just a number, a constant. This is an x, this is an x squared, x to the third, and x to the fourth. Meaning the answer starts off with 1x to the fourth, which we don't write down the 1. It's understood that there's only one of them. I only see one of them there. Plus x to the third. There's 0 of those, so those don't show up. There's 0 of those. Those don't show up. They're -4, and we have -5. It's a remainder, so it's over something. X minus, what was the second thing in the problem? So we look back at our problem. Notice the second thing is this, x minus 1, the thing we're dividing by. And in your case, for me, it's on 2 whiteboards. For you guys, it's like, I don't know, on the other side of the paper or above. If you don't want to look too high above or flip the paper, you can look out here, and you know it has an x with whatever the opposite of that is, so -1. This tells us that x minus 1 is not a factor of the big old long polynomial. So if we were to break it up into a bunch of different binomials, like with factoring and doing fancy factoring kind of stuff, you're not going to, one of the things in parentheses can't be x minus 1 because you got this remainder thing going on.
So it'd just be x.
What do you mean, just be x?
Oh, wait, never mind.
So it'd be something else. It could be x minus 2. We don't know. Okay, now I'm going to write down carefully the next one. The next one's not on the whiteboard. And I'm going to see if the 4 on the whiteboard are able to set it up correctly. Let me look for that one. Okay, so number 3. This is going to be x to the third power plus 4x squared plus 5x plus 2. That's the thing we're trying to divide into x plus 1. Okay, again, why am I doing this? Because I want to check if this is a factor of this. So if I were to do some fancy factoring, because there's a whole bunch of things in there, will one of the things in parentheses be x plus 1? This is a quick check, and if it is, then we can simplify this into something nicer looking for factoring. Okay, so set this up on the whiteboard, on your paper. If it's on paper, I'm going to check to see if I have any notifications. I have some from my 209 number. It may not be for you guys, but who knows? So set that up. Again, your categories for the inside of the big L are x to the third, x squared, x's, and numbers. What number are you putting on the outside of the big L? No?
-1.
Yes. Okay, so remember it's -1. You set this equal to 0 and you solve it. Notice so far I'm not giving you anything with like 2x and other stuff. It's always like x, because those are the simpler ones while you digest that. Okay. change that up. On the other side, I'm going to be setting it up and taking a second to peek at what people on the whiteboards are doing. So Tino and Angelina, clear your whiteboard, set it up. Let's see, what should it do? Big L. We said we're doing -1 on the outside. Categories from x to the third down to numbers. Again, good spacing is better. 1, 4, 5, 2. So 1, 4, 5, 2. Again, you always start off by dropping the first one. See if you can take it from there. By the way, on this lesson, you do want to have writing utensils of different colors, but a pencil for most of it is highly recommended, especially when we get to sketching some graphs. By the way, you're going to learn some calculus today. What's with the moan? You can handle it. Is Jasmine's moan the same as those at home? I remember if it was earlier in the school year, I remember standing here. I don't remember which one of the classes. I put some stuff on the board. What?
I accidentally exited the whiteboard.
Weird. Oh, you exited the thing?
Yeah, I didn't mean to.
Go back on and I can copy. Wait, what happened?
Oh, wait, it's good. I got it.
You sure?
Yep, it's back on.
Okay. See? I see Angelina Hema had correct remainder, so does Jasmine. Let's see if they translated okay. Good translation from Hema and Jasmine. Angelina's getting on it. Again, if you haven't set up the problem, Sylvie, you're on camera. We drop the 1 down. -1 times 1 is this. You combine these two by reading it off how it looks. 4 minus 1 is 3. Go back to the beginning. -1 times 3, bounce the ball up. -3. This is 2. -2. This is what we like to see. Before the last time that this showed up in whatever unit that was, that I said this would be for like later on, this is the later on. Because what's going to happen on some of our problems, maybe today or maybe we get to them tomorrow, we want to, in an organized fashion, either because we're looking at the multiple choice options, in your case sometimes, or on some homework practice stuff, it may be you need to just start guessing small whole number answers and putting them out there and seeing when do I get remainder 0, because you want to figure those out because the factoring is not going to help you, so you need to do that. This would be something like, I don't know, physics people are doing something with this. They would program a little app for themselves that will do this and like, okay, switch all the numbers from -10 to +10, plug them in, see, give me which ones are equal to 0. Because they want to know where are the ones equal to 0, because then it's going to like mean something about outer space or something. Okay. If you translate this back, remainder, oops, not x, number, because the categories go down in intensity, in degree, your answer will be x squared plus 3x plus 2, no remainder. And this guy, if you were to continue your problem, by the way, you would try to go one, like that and chop that up to 2 more parentheses. You already know one of the parentheses is x plus 1. What are the other 2? Because if you have all these parentheses, you can do the rest of the problem figuring out where are these zeros, these x-intercepts. Okay. Again, this is with synthetic division, meaning I'm just messing with the numbers. It's the same thing as long division, by the way. So I need somebody to give me Actually, there's a bunch of you. Let's see. 1, 2, 3, 4. Let's do that. So each one of you put a number in the chat for me. Put a number in the chat, a single digit number. I'm going to use them in whatever order they pop up over here. So that one was synthetic division, just to remind you what regular long division was. So put a regular number in the chat for me. Is that all of you in there? Or Jasmine, you can write it on the board or tell me what your number is.
Oh, okay.
Whichever way. I'll
There's
just
a marker.
always take my stuff. You can. Oh, I have 2 blues. There's that. Did I hit you?
No, I got it in time.
I missed.
No.
I was aiming.
Yes.
Because you scare me in the morning. So 5, 7, 8.
Oh.
Not that. Write down a single digit number.
Oh, a single digit number. So it could be like any number.
Yeah, I'm using some of the number. We'll do 2 of these. So this is number 4, right? If your number didn't show up the first time, it should the next time.
Eraser.
You need everything, don't you?
I just need an eraser. Come on.
Okay. So we're going to do this. Anybody want to tell me, how do I start this problem out? Who remembers how to start this one out?
You have to find a number that goes along with the 5.
It goes along with the 5. Why? Because if you do it with the whole thing, that's the whole point of doing this step by step. You don't want to do it with the 57, just the 5 if possible. And again, you have that much money. You have this much money. Everything at the store costs $4. Okay? How many things can you buy? Only one. And then notice it's similar to the other thing we were just doing. 4 times 1, notice outside times something is the number. We combine them, but the difference here is we always have to do the opposite of whatever we wrote down, 1. How do I continue from here? Someone not named Jasmine. She's over there finishing off the thing. What do I do next?
Bring down the 7.
Yeah, bring down the 7. Notice on the other one, we had this arrow for the first one, right? Okay, so now 17. Now you have more money. $17. Everything costs 4. How many of those $4 things can you buy? How many of those $4 things can you buy?
4.
4, because that's 16. What's your change? You want to know what your change is? Well, it'll be 1. Bring down the other one, 18. Again with the 4. So 16. And you're left over with 2, and which is our remainder. Okay. And again, with how do I write my answer? Well, you're going to basically go like a clock. Even if you're not fluent with the analog clock, I'm assuming all of you know it starts up there, right? And it goes around. You know that much. Okay. 144, whatever is down here. 2 over, what was I dividing by? 4, which is equal to 144 and 1/2. Okay. We're going to be doing this process, but there's going to be X's and stuff inside and outside. Okay. Again, long process. Some of you, if you had to compare, I'm just curious, which one do you tolerate a bit more? Long division or synthetic division? Synthetic division is the big L thing. Which one? Put it in the chat, or if you're in the room, tell me, unmute yourself. It's not like they're both, I don't know, the most enjoyable for people of your generation. Possibly. Which one do you tolerate a bit more? Big L? Regular division. Jasmine says the big L.
Because that way it's easier, like, you
Okay.
can write the solution easier.
And the big L, you have the advantage that things are broken up into different categories. Here you have to keep them out of the bringing in the down thing. Now for you to see what happens if I don't have the big L, or if the problem is not set up in a format for me to do that. Let's see that one. This, you want a pencil, something to erase. If not, you're going to scratch out stuff and then flip the page. Okay. I had to rewrite this problem like 3 times yesterday at like midnight. So I'm like, wait, this isn't going right. Something weird happened. Okay. So, what number were we on? 5, I guess.
Yeah.
I'll renumber. If our polynomial, again, a combination x's and numbers and stuff. X to the fourth plus 4x to the third plus 2x to the third. Let me check myself. No, 2x squared plus x plus 4 is divided by x squared plus 3x. Put it in here. What's the remainder? R for remainder, same little abbreviation from big L stuff. Okay. Trying to see if I can fit it in right there. Maybe. We'll see. No, actually, I'm going to do it on another board. So we're doing that division. The first thing goes on the inside of long division, right? Second thing on the outside. I'm going to use a whole board with nothing above it. That way you're seeing everything scrunched out. Okay, so leave room up here for the quotient. The quotient is the answer of a division problem. X to the fourth. Again, just like on the big L, do some spacing inside of here. Make your life a little bit easier. I remember in 7th grade, we would do competition with long division.
See who would finish the answer the quickest.
How do you guys think I would do? What do you guys think? Was I on the very slow part? Was I average or was I very fast? What do you guys think?
Slow.
Okay, Jasmine says I was slow. See how it is, Jasmine?
No. It's just, I don't know what. It's just, I feel like you're the person who takes it slow and you double check.
What do the rest of you think? Maybe she's right. So 7th grade, me with long division, regular long division, in, what was it called? That wasn't pre-algebra, it was like middle school math class. How quick do you think I was with the long division? Was I on the slower side? Was I average like the rest of them? Or was I on the fast side? Okay. They're being nicer just because, I don't know. Or maybe that's their opinion. Tino is going to remain silent. Or the gentleman, tell me how you think I would go.
No,
just so I know that you're there.
Because if you're the person who does the fast, you probably get your answer wrong.
Why? People.
Because I feel like you double check your work.
So you do it right on the first try, and then you do, the 4 of you who were on the whiteboard side were doing that pretty quickly. Had it done before I wrote down the thing. Actually, I was on the fast side. It was always me, one of my friends named April. She's of Chinese descent, and there was this annoying little white boy who nobody liked in the class because he was very stuck up, kind of thing. Everybody would cheer when someone would defeat him. Sometimes he would cry when he would lose. Okay. Sometimes it was always us three standing because we would all be standing on different boards like in our classroom here, and then little by little you have to stitch yourself down. I'm like, oh, I messed up today. Usually I would do it fast, kind of thing. My mom would say you're wasting time with showing the work. You should keep it in your head, because when she immigrated, that was something that the people immigrated from Mexico, that they would just keep track, because they wouldn't write anything down here. The stuff up here was correct, and they'd put little abbreviations next to it to keep track of things. No, you need to write it down the same as the rest of them who have never learned this before in their country. It's oh, that's wasting time. We're doing it right. We are showing work up here because there's different ways of doing this. So how do I do this? Well, we're going to match up the first one with the first one. He's there, but who cares? It's you. Maybe you nowadays, since you're older, your parents take you into account. But if you have a younger sibling, it's they're just along for the ride usually. So we have x squared. We need it to go up to x to the fourth. How many more do we need? If we're at 2, we need to get to 4. Another 2 more. Here's another 2 more. And let that process. So again, we start at x squared. We want to go up to x to the fourth. We need another 2 more. Well, that means we have to go outside times whatever's there. X squared times x squared, x to the fourth. 3x times x squared is 3x to the third. So just drop it down. No, that's synthetic division, big L. This thing is the other way around. You have to do the opposite of these guys. And this is where you need to be careful. These cancel, right? 4x to the third minus 3x to the third is just x to the third. And to the best of my ability, I'm going to try to color code things for you. And then, just like before, we bring 1 down. Okay, I don't care about the green one. He's a little sibling. Care about the parent or you, or if you're tagged along. Hopefully, you are not like someone that I saw with their younger sibling at me and my dad at the other day. Smart and Final on Stockton Boulevard. This girl who, she's sort of tall, and she's not very petite at all. Who she has a lot of strength, but she's all on her phone. Had a little short, like 4th grader with her. They needed to buy a big old bag of dog food. That thing is heavy. I remember when I go, my grandpa back in the day as a high school 6 foot tall guy with strength back in the day. That thing's heavy. She had him lug it around the store. Like, you care what? She's all just laughing at him. Ha 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 kind of thing. I'm like, that's hecka mean. You don't want to be like that. But here is older sibling, younger one. This is the boss. X squared. You want to go up to x to the third. How many more? I need 1 more. 2 to 3. You need 1 more. Here is my 1 more. X squared times x to the third times x is x to the third. 3x times x is 3x. It's the opposite of this. If not, then things wouldn't disappear. These go away because they're opposite. 2x squared minus 3x squared is negative x squared. As I'm doing steps, make sure you're checking what I'm saying and what I'm writing to make sure it's accurate. Up to right now, I think so. Okay. Oh, then we have to bring down something. Okay. We bring down this one. Oh, it's up. How do I make these match up?
Square root.
Well, not square. You know, I want to do square roots in this. Well, it's already at that. They're both x squareds, but this one has a negative, so it's going to be -1. Okay, to make it match up, negative x squared minus 3x, opposite time. Set the camera. Okay, these cancel out because the bottom one becomes positive. X, negative times negative is positive, so x plus 3x is 4x. I bring down the last one. I may want to check for something, but notice x squared, and then I have an x. It can't go down. It can only go up. Okay? So you're done. The bottom is your remainder. Remember, it's top. The clock goes to the bottom. It's at the 12. It goes down to the 6, and it goes back to the side. So your answer would be whatever's on the top, x squared plus x minus 1 plus 4x. Never. We're supposed to put plus 4 down here. Looks weird. What am I dividing by? Well, the thing on the outside. This shows me that if I were to do synthetic division, which there is an advanced way to do it, notice this wasn't a regular x, that's why I didn't do the big L. There is a way to do that. I don't know how to do it off the top of my head. Usually you don't do it in high school like that. Even Sac State college professor was asking him, because he was tutoring for you guys a couple years back, Travis. He didn't know of a way, if there was a way, he imagined like there might be. Nobody uses it though. This tells you that you wouldn't get a remainder of 0. So meaning this can't factor the other thing out. This is polynomial long division. When you can, I'm assuming you want to avoid this. This is you driving on the freeway in the fog and then in the rain. It's possible you want to stay at home or you're going to take the street or something. Keep yourself safe. Because notice you need to be very concentrated as you're doing that. Question, since I have some of you already drive and maybe have experience, some of you are learning the last time I asked you. I kind of think some of you haven't started. Jasmine.
I only have a driver's ed, but
okay.
I haven't taken
Question, because not everybody knows this who's driving out there. Are you supposed to put your high beams on when it's foggy?
Yes.
You can't see, you want your high beams on? True or false?
True.
Jasmine says true. She right or she wrong? It's foggy. Do we put the high beams on? More light? I see better? Is that how it works? Some of you are driving out there.
Wait, actually, no.
So what do you guys say?
It's a multi-window unknown space. So I'm going to say false.
So she's changed it. She felt Angelina's answer. Why is it a no and false? You don't want to do what one of the dummies behind me was doing the other day on Stockton Boulevard?
Because if you use high beams during the fog, there's a chance you're able to blind somebody else with that light.
Well, yeah, if they're oncoming, you blind them. Anybody know any other scientific reasons why it messes with you? It doesn't help you?
Because doesn't the high beam show everything, but when like you turn on your regular lights, you see whatever's in front of you?
Something like that. And then I remember some explanation that like with Angelina saying that the regular one's going like this. The other one is going to spread out the fog more like that. So it's making it even more foggy by your light because the fog is white. And you're putting white light on white light. So, okay, it's like you're putting the flash on and you're trying to see. And then you can't see anything. And you also want to make sure your lights are working because there was another guy who was like that. I felt sorry for that one because like maybe he just got caught out in the fog, out and about. Okay, now for what the 40% of the problems on lesson 2. Let's do one. It took a while to get things set up. Again, it doesn't have to be f of x. It can be g of x. The letter is just representing this is my calculation for this. And it's saying that we have that. You've seen problems that look like that. You've also seen problems that look like this. What do we want to do with this thing? We want to find the zeros. Why? Because we want to be able to sketch a graph for this thing. And we don't want to have to depend on graphing software, or we want to know how is the graphing software doing this. Okay. So we're going to show off our factoring skills. Let's color code things. This first section will be represented by parentheses in green. Okay. The second one I'm going to do with red. Let's talk with the green ones. How do I split this up into 2 different binomials? How does it get split up into 2? Or can you tell me what goes in the 2? Some of you forget the work, but you know how.
I was gonna say you're gonna have to square root.
Yeah, you do square root it. So what goes in the parentheses? Again, if you have color coding, now is the time to use it because you could tell that the green was not the problem, or just rewrite it. What? I'm gonna wash your stuff later. So what do I put in the parentheses? What do I?
You would have to do like x squared. Oh, yeah, x.
What is the square root of x squared?
Just x.
Just x. 1 over here, 1 to the right. What's the square root of 9?
3.
And -3 also. These two multiply that. This is called the difference of squares. That's what that technique is called. For this, it has 3 things. So it should be big X, but notice they all have X's. So that means that we need to divide something out of it. Again, there's 3 siblings. Some of you I know have at least 3 siblings. Some of you in one family from the classroom, I've actually had all 3 siblings. I've had 3 different siblings. From another one, I've only had 2. Maybe we'll convince the other ones who got sent elsewhere for the meantime for middle school. They better come over here, Angelina. You better convince your family. I was wondering why they were over there at Arden. Okay, so the 3 siblings, so it's to use the Aguila family. It's Jorge, Julian, and Giselle. Giselle's going to like the example. Julian will not. Who's the boss of this situation? It'll be Giselle.
Because she's the oldest.
No, because she's the youngest of the 3.
Oh, really?
Because 3, 2, 1. The youngest one, we're going to go with the youngest one for whatever reason. The youngest one got their way, as I say for my younger sister too. So we divide out of that. What's left over? 3 minus 1 is 2. 2 minus 1 is 1. That has no remainder, so it's 12. Okay. Then we have 3 things. We go like this. What are the 2 numbers that I'm going to use on my big X? Notice now I'm showing off all the different skills and saying now I do this, now I do this.
-12 and 1.
-12 and 1. What 2 numbers should I use? I have 1, 12, 3, 4, 2, 6. Which one is it?
I was going to wait.
And I think it threw some of you off that I actually told you numbers. Now they're floating in your head. Which one should it be?
Yeah, that's right.
So say it for the rest of them so that they can't see.
And -3.
So 4, 3 is 12. If you put a negative right there, it works. So let's put all our things from the red section. I have x. This big long one, because I used the big X, gets chopped into more bite-sized pieces with x plus 4, x minus 3. The green ones are sitting there. What you are looking at right now is factored form. That's what you want in order to see zeros, by the way. And something that'll be to your liking. I know Tino likes this part. When I say that he has to show less work. If you're not getting an answer, you better show like all the work possible. Okay? Do any of these things match up in parentheses? Do I have any repeats? Look through the greens and reds. Do any of them match up? Just to finish off this problem. I have any pairs?
X minus 3 and x plus 3.
Well, those sort of related because of plus minus, but notice the ones on the edges are both x minus 3, right?
You contribute these.
So I can put those together as x minus 3 squared. I'm just going to write all the rest of them.
Oh, wait.
Because the biggest, we'll talk about what degree this is in a second. We may leave this halfway. Okay, notice how many x's do I have? 1, 2, 3. This counts as 2 because there's right there, so it's 4, 5. The same thing we could have gotten from up here. 2 and 3 make 5. This is degree 5, meaning I need 5 zeros. 5 zeros are needed. Where do I get them from? Well, make an equation that equals 0. The first one equals 0. Well, there's one answer, right? Right off the bat. The second equation is this. The answer is the opposite. The next equation is this. The next answer is the opposite. The last equation is this. You do square roots and stuff. But since there's nothing over there, you still do the opposite. This is called a double root because it had an exponent of 2. Roots and zeros mean the same thing. These are the answers. Okay, this is how we use our factoring. Why we do the big L is to figure out these little parenthesis things, by the way, without factoring, because if it's like really complicated. And many times in the lesson, at least in the practice, we'll give you the factoring. Tomorrow, we're going to start dealing with how do I use this to make a graph. Make sure that by tomorrow, you're done with practice and mastery tests. Don't know if you've gotten in there yet. I know some of you haven't when I was unlocking the second thing. And you can start on practice number 2. Need you caught up. If you haven't loaded the work, Tino, load it up. Jasmine, make sure you're caught up with math, not just doing English presentations. See how it is?
No.
And I'll see the rest of you later.
Presenting today.